Hey guys, how's everything going? This is JSer. Today I'm going to try to solve an algorithm problem called maze solver. So basically we're given a 2D array with zeros and ones indicating empty cells and barriers, and we need to move move a star from the top left cell and try to go to the exit, which is the bottom right. We need to return the path. It's kind of interesting problem and the typical DFS BFS stuff. So let's try to do some visualization. I forked a empty repo from StackBlitz. I'll put the link in the description. So if you're interested, you can take a look and fork it as you want. This is just the boilerplate code. I'll try to remove it. Let's just write down what we want to do today. First, we need to render a map. I would say no, render a maze, and also we need to render the path. Also including the steps to find it. Cool. So for this app, we need first to render the maze. I'll use a wait a minute. So for the maze, it's just a 2D array. So let's use some state. Set state, initialize it with okay. Let's create some function create maze to make it simple, not simple. Okay, that's just I want to use a what is that, square? But yeah, I think we could just use the M and N stuff. Okay, M is columns. No. This is rows and columns. Create maze. We would return new array, which is rows, field 0, map, new array, cause field 0. So this is the create empty maze, right? Empty maze. Use state. We let's first try to create a like 10. Import state from React. Cool, and then we just render the state. We could use we use the grid. Here is just this container class name equals container, and for each cell we render it. So state wait a minute, how should I put it? Okay, anyway, should we flatten it with the CSS grid? Yeah, we use CSS grid, and this we could just use flatten it. State flat map. There's no flat. State is any 0. Actually, we should. Yeah, let's just add some type array number. Target library to ES20. Oh, there's no flat. How can I change this? How can I change this? Oh, geez. There's no easy way to change it. Okay, React script. Let's use React script. Oh shit. Okay, I don't like it, but there's nothing we can do now. But anyway, it should work. Just ignore it. Map. This is map this is number. We render just a div, class name equals cell. Okay, we're just num div. Okay, the index we needed key equals I. Great. It's not working. Oh, sorry. Cool. And we go to the style, say grid, which is display is grid. We need to set the columns and rows, right? Okay, let's say cell width is like, I don't know, 20 pixel. Height equals 20 pixel. Which is class name equals cell. And we need a border actually. The border, we could do something border right. So for each cell, we set the border right, solid, just use border bottom. And we add the top border and left border to the grid. Border top, border left. I think we could do it better. But anyway, it doesn't matter for now. Cool, and because the grid is we cannot set it into the CSS code. So let's say row equals 10, columns equals 10, and we create, this is rows, this is columns, and also for here we need the inline style equals grid template rows, which is rows grid template the columns. Oh, it's just not, it's the rows, it's repeat one frame. No, not repeat this. Repeat the cell. Okay, this width does not work actually. Let's say return 20 pixel rows. Am I right? I'm not sure. Let's give it a try. This is columns. Obviously it doesn't work. I forgot the grid. Style and grid template. Huh? Interesting. It's not working. Let's see. Grid template rows. Repeat from. No. 20 pixel 10. Oh, it's not working. What is it? Shit. Grid template rows. There's no repeat. Oh, okay. The count is the beginning. I should have used the count first. Shit. Okay. It's still not working. Oh, columns. I think there's no such shortcuts. Okay, it's not working. Grid template rows. Sorry. This is really bad. Yeah, it's working. Oh fuck! Ah, jeez. I'm so stupid. It should be on the container. Okay, so we have 10. We have a 10 by 10 grid. Doesn't look good, right? So let's say the cell, display. That's just the inner grid. And then place content center. Should be center. Cool. And it's a bit of small. Let's make it bigger. Like 40. Cool, it's better. So now we have a grid, and this is the exit. This is the start. So we're going to start the algorithm. We need to render each step with some interval. What does that mean? Is that for the algorithm we would just calculate the new grid, right? With 0. Okay. So 0 is empty cell. For 1, it's barrier. And like say 10. Okay, 10 is the solution. Yeah, so do it like this. So if it is 0, okay, we need to render the if 0 we're into nothing, but if it is barrier we need to make it black. So class name here, of course we need the cell, but also we add some called like barrier background. Let's say it's black. So here, oh, we need to randomly fill up the maze, right? So create empty maze, and this one is count of barriers. Okay, this is constant maze. We randomly fill them up. So while count of barriers is bigger than 0, it's just to create a function called to generate a random number. So random return math. Cool. Row equals random rows. If maze row, I think this also easier. It's prone to error. Let's just say get cell maze, it is 2D array, row number, column number, return maze row call. I think we could add some validation here to do validation. So if get cell row column, let's just also we need some const, right? Const values, and cell values empty equals 0. We could use enum here as TypeScript. So yeah, we should use enum here. Enum cell stat values, yeah. Empty 0, barrier 1. On the other cells, we need to render like the path is path, let's say equals 10 here. So if get cell, if it is equal to cells, if it is not equal to empty, then we continue. Otherwise, oh, we need to maze. Otherwise, we can put it there. So otherwise we set it. So set cell. Okay, let's also set cell. Set cell value itself values maze. Oh, we also need to validation value. Cool. Set cell maze row column, and that sets the values cell values barrier. And also we return the maze. Awesome. So this is it. Okay, barrier like 100, so we get 10 inside. And now we render if the num is barrier. Okay, let's get the we need to get the name actually. Okay, also we also need to get the color. So function get cell color value cell value switch value cell value empty case return transparent. Okay, if that's the case, we don't need the get a class name, I guess. No, it's just a okay, this is not easy. Get cell class name. I don't like it. Let's just use the direct color here. Return transparent case cell values barrier return black, right? Case path return red. So color. For other cases, we need to default assert never value. So function asserts never, it should be never throw new error value is not handled. All right. So if we're not handling it exhaustively, it will be an error here. Cool. I think we need to. We can move this into different files, but let me. It doesn't matter. Let me put it here. Just some util functions, and now we get the color. So here, we could put the cell and the style, background color. Okay, cell color. No. Oh great, now we have the barrier. Looks like we could find a path like direct like this, right? Let's guess just to give it a little more. Let's give it like if 20 barriers. Oh, we're blocked. Jeez. So our this is stupid. We need to avoid the start and end. if row equals 0, 0, continue. If row equals rows, this is not a very good algorithm to initialize the maze, which is randomly. There might not be in a solution, but we just use it for demonstration, so it should be fine. Cool. Okay, so now we're rendering a maze. Let's start with the algorithm part. When we run the algorithm, we'll put it in the use effect, because once it's rendered, we would calculate the result, and also we would store each snapshot when we set it, right? And put it into a snapshot here. So I would say we wait a minute. Okay, so I think we need to use a snapshot here. So let's see. For the algorithm, need the snapshots. Render the snapshots with the interval. So what does it mean? Okay, so we need sorry. We create a snapshots array. So snapshots ref is use ref. So it should be an empty array, which is use ref here. Or we can just put it outside, but I think use ref is better. And we use an interval to get the data from the snapshot and put it into okay, we don't need it, so we only keep the snapshot index. So index const index, set index equals state 0, use effect. Because in the dev mode there it will be double rendering issue, so let's create another function just to make sure the effect is rendered once. So use effect once, callback, const used ref is use ref false. Return use effect. Callback. Or is it? I don't know. Anyway, let's just try to use it. So if used ref current, we do nothing. Otherwise, used ref current equals to true, and we would run the callback. So here we use used effect once. We would set just some mock data. So snapshot ref current push create empty maze 20 20 10. Oh, this is depth. Okay, it's depths. This should be use effect once. Depths. I think there's a type for use effect. What is this? Reactive dependency list. Okay. Let's use it. Looks the state is not defined. Of course. The snapshot is snapshot. Just put it here. Snapshot equals snapshot of ref, the current index. If there's no snapshot, return null. Otherwise, we would have the snapshot, which is actually the state. Okay, we need to set the index. Set index. Wait a minute. Okay. So here's the problem that when we set to the snapshots. Okay. We set it to now. Cool. No. Default is 0. We need to trigger the render, but now. Okay, we could use set it -1. Okay, set index. Now we're able to set it to 0. So yeah, it should be rendered. 2010. What happened? Repeat this. 3 10 rows. Three, 6, 9, 10, 10, 10. 20. Huh? Oh, I'm sorry. There's no such. Rows. Columns. Yeah, I'm sorry. If this is 20, then we have 20. This first is 10. Cool. And then this is just a start. We would set an interval here. So this is mock data. We will create a use effect once again. This is a set an interval to flush the snapshot. Okay, so here I'll comment it out. It's a bit different. So index, here is the index. So if snapshot ref, okay, so this is not easy. So length count equals snapshot ref dot current dot length. If index, okay, it might be empty. So if it index is smaller than count -1, we would Oh, no, no, no. If that's the case, the index are not able to be updated, actually. Oh, it should be fine. If we want to like do some step traversal, previous step, next step stuff, it will be more difficult. Anyway, I think it should be fine here. This is just a move to one step, right? So function move render. Okay, next step. Set index. No, it's not working, I guess. This is not working. Set index, index +1. I think the step will be an ref as well. The only thing that should be different is the oh, wait a minute. Oh, okay, I don't. Oh, no worries. This doesn't work, actually. Yeah, I use the function notation would be fine. So set index, which is the current index, and we get the count. If count is smaller than index, no. Next is smaller than count, -1. We return next one. Otherwise, we do nothing. Return index. This is the next step. So, and we would the window set interval. This is the next step, and let's create a const here. One second. And return const timer. Great, and now we can start render the map, right? So yeah, and use the effect once we start the maze. Init the maze. For each step, we would push the snapshot. So we need to deep clone it. Yeah, we could just do here. And create a function called create snapshot, which means that snapshot ref current but push. There is a method called structured clone. Okay, it's deep clone. So those structured clone maze. We push it, and we could just create a snapshot. Yeah, it's working. And now we start the the algorithm. Okay. Wow, it's already 35 minutes. I'm not sure whether you're with me or not. But anyway, start the algorithm. The first thing is that we need to determine whether we have a path or not, right? So as always, I would so first the question, whether it has the path or not from top left to top bottom right. So basically there's no such thing we could know before we moved there. So from the top left, we just keep walking around, right? Okay, so walking to the right, and then right until we get to the border or to go to some barrier. And then just keep walking until we find the target. So basically, if you think of like a tree, from here, we have two options: is to the right or to the bottom. But generally, we have three options, right? From left, from right, and but we cannot go back. So have three options. The tree would have get three branches, and for each step further, we have three branches, and then so if there is a path to the exit, there must be a node on the tree, which is the target node. So this is just basically DFS approach. For that tree, the depth will be maximum, like cost us all the nodes, right? So it will be m times n, and then for each node we have three branches. So for each node we have three branches, so 3 to the power of n, so exponential, right? Is the word right? Exponential? Exponentials, not exponential, sorry. Exponential, yeah. It's exponential. Could we improve it? The problem one has path or not. Basically it's 3 to the power of n, I think. It's upper bound. It could be better, I think, but generally it's exponential. I think the tree itself, we could actually memorize it. We could, like, when we go deep down to this route, after we fail, we could mark this as it's not appropriate. It's not, it won't go to the exit. So for that, we could cut down some subtrees. So in the future traversal, we would stop here. So that means for each node itself, we maximum would cost we would wait a minute. We won't walk on the subtree from this node ever again. Once we know that it's not walkable. What does that means? That for each node we would basically cost 3 nodes to determine if it is it has a path or not, right? So that needs us to how many checks there? It's still exponential. So for no, I'm a little confused. So for here we have it, so we would stop here, and then here we would check it can, right? All right. There is a path here. So for each level, when we go to the leaves, when we come back, so for each leaf of the tree, we would stop going to that node again. Oh, how can I? I'm not sure. What's the time complexity? But has path or not? I am confused. Suppose these are all available empty cells. When we go like this, keep walking strategy, we walk until we find like we cannot get it here, so we cannot go here. Suppose the barriers are just blocking. We can never go to the exit. We would actually walk once it stop here. Says it cannot be. It cannot be. And then we would mark it as cannot be. Cannot walk from there, and we would go to the previous level, and then find another route. But that means. What does that mean? That means for each walk on the node, for each try on the node, we use maximum 3 steps. So if we memorize the available, the state, okay, the possible, the result for each cell, we need maximum 4, including the backwards check. I think it doesn't matter. So 4 checks to determine if it is good or not good. It is if there is path from that node or not, right? For 4 checks. So for here, we have 3 checks to check it, but for here, we have another 3 checks to check it. But so for each node, we only check 3 times because we've already memorized the state. That means we would actually go to an m and n time complexity. Actually, is time of 4, right? So if we memorize the state, so it's, yeah, this is the time complexity. Is it right? Let's just revisit. So because for each node, we will only cost 3 checks. Here, here, here. If it is this one, here, here, here. So for this one, here, here, here. If there's a possibility that go to this way, but then we cannot go there, but go this way, we can. This is a good question. This is a really good question. We cannot go back. If that's the case, we could store the status of whether they can for 4 directions. So sorry. Yeah, by storing the directions, the result for 4 directions. Yeah. So it means that maximum there will be 4 directions to check. So it's still the same. Yeah, it should work. Because once we store the directions, say, like say, if we can go get to the exit from this direction, or from this direction, or from this direction. If there's one direction unchecked, then we can just go that direction. So anyway, the direction will be stored. The status will the result will be stored. So for each cell, so how many directions are there? So for each cell there will be 4 directions. So each one there will be these kind of directions. And this direction for each direction, it will be determined on the next direction. For each direction, it will be determined by the next 3 directions from the next cell. So I think this will be times another 3 something. So here, here, here. Ooh, this is tricky. Am I right? I'm a little lost here. When we are traversing the cell for all possible route, like say we go to here, we cannot move it forward, right? It's that, and we go, now we have to go above, and then this direction is already dead, and we go above and blah blah blah, go here. Suppose we stop here, stop, like there's a dead end, we go back and then go back to here. It means that we cannot move forward again, go this direction. So we can like say we don't need to check this again. It means that is that the same? Oh yeah, there might be a solution, like say from this dead end to another the opposite direction, but obviously we cannot go to that. Anyway, I think this makes sense. It means that for each cell there are 4 directions. We can use the 4 numbers to store the status, and it will just, and that will determine whether we can move forward. We can. That will determine the status for that cell. And yeah, I think this is it. Cool. Roughly, I'm not sure I'm right or not. Just to leave the question mark here. Cool. Let's write the code. Let's say function walk like row, column. We start with 0, 0, and when while we are working on it, we would set it to try, another state called try 2. If it's case try, okay, the path would be green, right? Green. Cell values tried, return yellow. Okay, we set while we work on it, if row equals rows -1, and co equals column 1, return true, and we set it to set the set cell, row, column, path. Yeah. Oh no, cell value path. We need to set. Oh, we need another one called function set cell is maze, create a snapshot. Cool. And if it's not, then we would work on it. It means that we don't need the try now. Yeah, it's all path. Okay, let's just use try for now. Try is better. Try 2. We set it to try. Okay, now. Okay, so now if the get cell maze row column is cell value dot is barrier, we just return false, right? And otherwise it is not goal, it is path. We cannot walk it on again. So get cell maze. Okay, let's just use include cell values barrier, cell values try. Let's remove the path, it doesn't look good. Tried includes okay, we need to ignore the syntax here. Cool. We return another one. Yeah, return false. Otherwise we could work on it, which means we need to set cell, set it to try. I need to recursive they walk on the next on the adjacent cells, right? So basically if we need to walk on the others, so if walk row +1 column or walk row -1, go up, or go down, go. This one is go to the left, go to right, walk row -1. If we can, so there might be invalidation, right? I need some out of boundary. Or row -0 or con -0. If any node could be walked on, it means that it's available, then we return true. Right? Return true. Otherwise, we return false. But when we return false, we need to go to the other direction. When we walk on this one, we will check the other date. This will be some loop on it. It will, like say we'll go to this one and try to go down, but it's blocked. We return false. This knot doesn't work. So go back and go to another direction. So this should work actually, I think, but it's not very performant. Let's say console. Let's walk 0, 0. Cannot read properties undefined 61. Yeah. What? Oh, this one. Sorry, I need to move this before this check. Cool. You see that it's not working. Set it. Oh, I need to create a snapshot. So yeah, we can see it's searching. You see when we go back, I think we forgot to reverse it. So I think we need to because when it's false, we set it to empty, create a snapshot, and we make it quicker. The interval, it's so costs too much time. White. What happened? What is wrong? Let me comment this out. Okay, it's working somehow. I don't know what it is. Go up. right? This, oh, okay. What? So, I don't know if it's right or not. So we found out, huh? So it's not stopping? There's something wrong. Why it's continuing? I think we should stop somewhere. We found it, we return true. And if it is, we return out of boundary. We return false. Otherwise, we set it to tried. Yeah, we tried it. And we create a snapshot. And then we will walk down the other route. We found it. Maybe there is something wrong here. Yeah, I know it. Let's update the interval to 500. It should be quick enough. So you can see this is really not performant, but it's trying. Oh, you found it. There's something wrong here. Okay, we console log. Find the route. There's something wrong. And route, yeah, true. Let's see what is the route. It's that. So it's not reset? Yeah, that's wrong. I think we should reset. Okay, let's try it again. Okay. Because we try to go down first and then go up. This is really stupid, right? Okay, interesting. Go up, go right, go up, go up, go right, go up. You found it. What the fuck? Try it again. Go up, right, down, right, up, down, right. This is stupid. Why there's no dead end? It's hard to find some maze with a dead end setup. There's no dead end at all. There's a dead end. Let's try. What happened? Yeah, this is not dead end. This is not dead end. This is not it. I think we need to increase the barriers. Yeah, now we have more dead end. I think this could be some. Go up. Go up, right, down, up. Up, dead end. Nice. Go up, down, down, up, 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 up. See, this one is, you can see that this is a perfect example of how it's been trapped. Go up. It cannot go up and go. You'll try it again. This is a great example. Okay, it's kind of like it's been trapped there. You'll try all the possible route there. Jeez. You see that it's trying very hard. For each snapshot, there's actually a step. So yeah, we found the route, and as we said, it's very not performant. Let's try to find the route. Okay, const result goes walk 0. If result console log, find the route with snapshot at the length. Snapshots that length just steps. Not found. What? Yeah, 4082. Let's just jump straight to the last one. If that's the case, we could change here. Not increase by 1, but just to return the count. -1. Gee. Somehow it's... No, it's... Well, it's calculation savvy, but it should not freeze the browser. What? Okay. I need to close it. It's not responding. Fuck. Yeah. Okay, so we can see this is the route being found, I guess. This is the case. So how can we, this is just to return the result, but how can we get the path actually? How can we return? How would we return any path? I think the code would very much stay the same. We copy the code here and close the tab. So while we're walking, we update it, but on the other hand, we would use a path actually to hold the points. So yep, and then we walk console log walk 0 0. While we set sail to try, we push the path in it, which is row column. If it is not, we set it to empty, and also we pop. And when we find it, we walk we find it, we return it, return true. Okay, we stop. Okay, we could use a global one, so const path to hold it. Without this one, if it is not working, we pop. And console, no, not console log walking 0, but so walk path. Yeah, I think it should work. Let's give it a try. This is the final path. Let's see if I have some thing. Yeah. So 0 0 1 0 1 1 2 1. So this is just the path. Okay. So yeah. This is the 28th. Obviously, it could be shorter, right? So here's the third problem. How can we return the shortest one? 3. How to return shortest path? This is interesting. So by shortest path, we use DFS to find any path, but it might not be the shortest. By shortest, I think we need to use BFS, meaning we try to reach the cells with shortest amount of with the minimum count of steps. So from here, step is 0. From this to cell, from step is 1. And then we could map all the empty cells with the steps, right? So we can get the shortest number. But on the other hand, how could we know which path is it? So while we are moving from this cell to this cell, with BFS, move to this layer. We would keep track of this cell with we keep track of this cell with an arrow with the coordinates of previous one, I say. So we could create a use copy this maze with 2D matrix to store the previous step, the previous one, previous cell to it. And then when everything is done, we could just start from this one cell and then check the direction to which cell is it, and then go backward, right? To find the path. Cool, let's give it a try. So how can we store the previous nodes? We could just store it in a JavaScript array because it doesn't matter. Let's make it better. We store the arrow and store the arrow. Cool. And we need some other values, right? When we pushed it, we need to set it, and when we first reach it. So here's a problem. We could reach a cell with the. Okay, it doesn't matter because when we can reach the cell. Wait a minute, does it work? What if we have a dead end? Suppose we can go to this one, and it moves from this cell, then we can say this previous cell is this one. Because because we're moving from the start to the entry point to the exit, so it should work, should fine, right? There's no code going back, because if there is going back, then it means it's not. If there is, we can't go back, then it means that it's not shortest path because we've already traversed it. So it should be the shortest path. Yeah. And the first one coming to it will be the shortest one. If they have the same step, we should not override it. Cool. Let's give it a let's give this a number, tried. We use tried here. We add some other values like tried from top equals 3. Tried from left equals right equals 4. Tried from bottom 5. Tried from left equals 6. So here, case, we all should be yellow. So case cell values tried from bottom, from top, from right, from left. They're all yellow. Why it's not fixing? Oops. What? Preset not specified on. What? What happened? I didn't edit anything, right? Preset not specified in configuration. What the fuck? Syntax error? Huh? Expected, comma. This? What? What happened? I don't know what happens actually. Preset not specified in configuration. Come on, man. This is ridiculous. Oh, 261. There should be a parenthesis. Where is the parenthesis? Ah, shit. I know where it happens. Somehow I made a mistake here. Okay. This one I should not comment it out. Ah, stupid. Cool, shortest path. Yep, we've get 4 directions here. And let's open it. So we would use BFS here. BFS and store the previous cell in current cell. So for BFS we will use Q. So we put the first one 0, 0 in it. So while it is, while the length is not 0, we would get everything out. So constant length Q dot length while length equals 0, length equals. We would get the head out. So head equals Q dot pop. No, shift. So here, when Q is in it, we would place a color. So it should be set cell maze 0, 0 cell values try. Create cell. There's, oh yeah, there is create a snapshot. So we create a snapshot here. Yeah. And again, get the head out. For each head, we would push the adjacent, put adjacent cells in the queue. Well, we need to check if it is okay or not. So let's say the const I can do it better, but here we just do it like it's pretty stupid. So top equals which is top equals get next cell, which is head direction dot top. We create a direction here. Enum const direction. Please enum direction top. Top equals -1 0. Bottom. Oh, enum cannot use. Oh, computer print. Okay. We just use an object. And top, bottom, left, right. And also we have a util function called function get next cell core array number direction type of direction. Okay, it's the same. So array number cost row equal 0 plus direction 0 plus column row return null or return row com. So we get next cell. Oh, also, yeah. Also, we need to check if it is valid or not, right? So if top is not now and it's not traversed, we need to stay check if it is traversed. So we already said it is tried. If it is tried, then it is not okay, right? Yeah. Okay, let's set some maze here. Array number And also we need to check if maze row com is not cell values dot empty. Return no. So yeah, so this includes if it is already tried, it is not okay, and then it is barrier, it's not okay. Other direction tried, they're not okay. So if it is not now, that means it's empty. And then we could put it into the queue, right? So we put into the queue, so push top. And also there might be duplicates, right? So we need to set the cell now. And we set cell top 0, top 1. So try from top. This is top. I think we need to this is really stupid. I can use a while loop here. I think this is get value from direction. Values for direction. Okay, function. Okay. Get cell value from direction. Type of direction. No, type of direction. No. Direction. Array. This is not good, actually. Okay. Switch direction. Case direction top. Turn. Try. Okay. I think I can just store the direction there, but it doesn't allow me to use something like this, right? Okay, this is pretty stupid. All right, let's just use some mapping. Try it from top. Case direction dot bottom. Return cell values dot try it from bottom. Doesn't look right. Return cell values. Try it from left. Case direction. Right. Return cell values. Try it from right. Default. Throw new error on handle direction. Okay. Cool. We get the cell value, so full const directions. object values direction. Yeah, for const direction of directions. Next, direction. If direction is not now, we push the next, and we update the cell from here. We should get a cell value from direction, and then we create a snapshot. And then we would update them until the queue is empty. And when it's done, yeah, I think that's it. And when we find it, we should stop. Yeah. So if head equals rows and head 1 equals columns -1, then we should break. Here's outer, break outer. Let's see. You see, we get everything traversed, and yeah, and the thing is here interesting is if here we get arrow. No, here num equals cell values tried from bottom. If tried from top, if it's from top, we return like the arrow, right? Unicode arrow. If from top, then we get this. If it is from right, if it is bottom, go up. If it is left, go to this. No. We got wrong. If it is from bottom, it means we need to go backwards. So this is it. Shit. If it is bottom, then this. Right. We should use the. If I'm right, then we use right. Otherwise, we use left. Otherwise, we just render nothing. Let's see. So yeah, we start from here. What is? Something wrong here. So here. Oh, it's wrong. Salve it. Wait a minute. Direction. And get a cell value from direction. This is from next one. So if the direction is from top, then the direction is from top. Then it should be pointing to the bottom. Oh shit! This is left. if it's from top, yeah. There's something wrong. Wait a minute. Something wrong here. We get the next direction. The direction is wrong. Top. Oh yeah. Direction. This is too top. Ah, God. If it is too top, then from bottom. Fuck. The direction is top, then it is from bottom. If it's bottom, then it's from top. If it's left, then it's from right. If it is right, it's from left. This is stupid. Cool. So you can see now. Oh, this is unreachable. That's good. Here, yeah. So it means that we have. So this means these are the same. Because if it is already set, then if it is already set, we've already, yeah, here. If it is already set, then we won't update it. And then we go backwards. So now, go backwards to get the shortest path. Cost path equals cost start equals row so we start from here. We can go the direction, the first direction we take. So here, go up. If it is up, then we go up. Go down, go left, go up. Go. Yeah. So this is the route. This is the path. So while maze start 0 start 1. While it is an arrow. So let's say if it is bigger than 2. Is arrow, so function is arrow cell is arrow cell value arrow cell value cell value cell value cell value if it keeps to be arrow get cell maze. Path push, and then you do reverse it. So path push, push cell. No. If there's an arrow, we would update it. So cell equals wait a minute. Value is direction, right? So if it is arrow, we need to get the map the this is stupid. Get the value, get direction, get direction from cell value. Cell, this is cell value, cell values. So if it is switch file, if this, we'll return top. If it is top, we'll return bottom. This is stupid. So we get the value, cost direction, get value, which is get cell, this cell, cell 1, 1, direction 1. And also we need to push the cell. Oh, we should create a new cell. So let. Cool. And then we reverse. Reverse, we have a new path, right? Let. Then path reverse. If path.length set a flag, let path found equals false. True. If path found, else also log path not found. Also log path found. Cool. So now we restart it. Again, somehow it's freezed. this is some bug or some bug in my code. Oh, come on. Oh, okay. Great. So now if we go to the path, it is only 910. So we don't find it? No, we find it actually. Path found. Shit, there is some problems in the path. Here. Cell value. Bottom, left, right, top. Okay. Yeah. Direction. We would get direction. Get cell. And cell. Oh, I think. No. So this should be the reversed direction. So if it's moved from top, then the direction go top, then it's from bottom. So the direction is actually to bottom. If it is top, then should be, if it is from bottom, then it should be top. No. If it's from bottom, then it should be bottom. From top, then it should be top. Okay, this is Jesus. This is not good. Okay, let's just reload it. Pretty good. So we find it. So 18. So we can see the path is 0, 0, yeah. 0, 1, 0, 2, 1, 2, 2, 2. And then you can see we go to 2, 3, 2, 4, 3, 4, 4, 4, 4, 5. And go straight to 9, 5. Yeah. Awesome. So yeah, we got the shortest path. And what's the time space complexity? So for here, we use a queue to cache all the cells in one layer. That means that it will be extra space would be mn is for the space, and for the time, interestingly, is that each node actually will be traverse maximum for once will be added in the queue, right? And it will be never come again. So actually, it should be the time will be linear time as well. Cool. So for the shortest path here, we haven't improve it. So if we improve it, we actually could achieve something similar with the time and space complexity. Great. I think that's it. Oof. Okay. Cool. That's it. Hope it helps. And actually, I'm going to clean up my code a little bit, and for you to read it easier, and maybe add some switch here. But generally, that's it. Hope it helps you next time. Bye bye.